These are the two questions that we are solving in electromagnetic induction. See the first question, what it is. The magnetic flux linked with the coil is given as phi is some equation. The magnitude of the magnetic induced EMF is how much? At the fourth second will be how much? We know the formula for the induced EMF is minus d phi by dt, which is saying that they are in opposite direction. But in the problem he is asking only about the magnitude of induced EMF. So magnitude of induced EMF equal to d phi by dt. D by dt of flux is given for you in the problem. 5t square plus 3t plus 16. So by differentiating this with respect to time, I will get the flux, right? So how much is this? Using a formula, differentiation of x power n equal to n into x power n minus 1. So differentiation of t square will be 2 into t power 2 minus 1. That is 2t. So differentiation of 5t square means 5 d by dt of t square plus 3 d by dt of t, this one, plus d by dt of 16. 5 d by dt of t square is 2t, as I have told you. dt by dt is 1, so this is 3. Differentiation of a constant equal to 0. So the induced EMF is 10t plus 3. So induced EMF in total 4 seconds is 10 off, in the place of t you write 4. That becomes 43 volts. Induced EMF in 3 seconds will be 10 off, in the place of t you write 3. That is 33 volts. So in total 4 seconds 43 volts. In total 3 seconds 33 volts. But he wants the induced EMF in the 4th second, at the 4th second, at that particular second. So we can write EMF, induced EMF at 4th second can be written as the total EMF generated in 4 seconds minus the EMF developed in 3 seconds. Total EMF generated in 4 seconds is 43, as I have proved. In 3 seconds is 33. So the EMF generated in that 4th second is 10 volts. That's how we solve that problem. That's how we get to the answer, right? That's one problem. Let us see what is the other problem is. This is given in NEET 2019. The question says a coil of 800 turns. So the number of the turns are given in the problem as 800. Has an effective area of 0.05 meter square. Effective area of 0.05 meter square. In a perpendicular magnetic field of phi B equal to 5 into 10 power minus 5 Tesla. When the plane of the coil is rotated by 90 degree, that means it is rotated from 0 degree to a new angle of 90 degree around any of its coplanar axis in a time of 0.1 second, what is the magnitude of induced EMF? The formula is same. Induced EMF magnitude is d phi by dt. This time is anyway given for you 0.1 seconds. In that time, how much that d phi changes, we have to find out. Yeah, let's try to find out. We know d phi is b dot a for one turn for n number of the turns into n. That is BAN cos theta. So I can write phi 1 initial flux is BAN cos 0, and when it is turned by an angle 90 degree, final flux is BAN cos 90. So delta phi is final flux minus initial flux. That is BAN cos 90 minus BAN cos 0. We know cos 90 is 0, cos 0 is 1, so that is equal to minus BAN. So if you calculate the magnitude of flux, that is BAN. B value is given for you in the problem, 5 into 10 power minus 5. Area is given for you 0.05 means 5 into 10 power minus 2. Number of the turns are 800. 5 into 5 is 25 into 8. This is 10 power minus 2. This is 10 power plus 2. Both of them can be cancelled. What is remaining is 10 power minus 5. 25 8s are 200 into 10 power minus 5. So the value that is remaining is automatically 2 into 10 power minus 3. That's the Weber magnetic flux that we have. That implies now I can write induced EMF as d phi by dt. d phi is 2 into 10 power minus 3 by dt is in a time of 0.1 seconds. That is 2 into 10 power minus 3. 0.1 on the numerator becomes 10 power plus 1. That is 2 into 10 power minus 2. That is 0.02 volts. That's the answer for the problem. So that's how simply we solve these two problems, and both of them depends on very core definition of induced EMF as rate of change of magnetic flux causing it. Once you know that and you know the formula for the flux, you can solve both these problems. Both are very simple and casual type of problems. Thank you for watching.